Good evening, guys. Are you able to hear me? Those who are online, are you able to hear me?
Yes, sir. Yes, sir.
Your voice is low, Ma. Can you speak again? Okay, clear.
Yes, sir.
Very good. Okay. So my screen, is it visible? Like, are you able to see the PPT?
Yes, sir.
Okay. So can you tell me what is the topic you're able to see?
Wheatstone Bridge.
So shall we get started?
Yes, sir.
Yeah. So can you guys keep your video on? Master?
Connected.
Hmm. Yes. Shall we get started? I'm sorry. Please confirm if my voice is audible.
Yes, sir. You're audible.
Yeah. So it's better, no, because I'm just walking away from the laptop. I'm speaking through mic. You guys have continuous voice, right? There is no breakage. Am I right? Am I right?
Sir, it's clear.
Okay. Okay. That's enough. So the last topic that we are supposed to see, right? The last topic that we are supposed to see in the chapter is Wheatstone Bridge. Okay. So it's called as Wheatstone Bridge. See, we had been seeing different laws that are there in this chapter. Like we saw what is Ohm's law, then we saw what is Kirchhoff's law. In Kirchhoff's law, there are two laws, right? One is the Kirchhoff's current law, and the second is the Kirchhoff's voltage law, right? And I told you in problem that Kirchhoff's current law and Kirchhoff's voltage law are combined together. They are not applied individually, right? They are not applied individually. They both are combined together and applied. Now the next question is there an application of this particular law that can be applied in a real-time scenario, right? And that is what is this Wheatstone Bridge. So it is an application of Kirchhoff's rule, and the circuit looks something like this. So the circuit looks something like this, which is shown here. Okay. Now, the point is, why do we even need this kind of a circuit, right? So when you observe in real-time scenario, you will have, if I give you 4 resistors, okay? Let's say I'm giving you 4 resistors, out of which 3 are known and 1 is unknown. Right? We have 4 resistors, out of which 3 are known and 1 is unknown. And our interest is to find what is the value of this unknown resistance with the help of this kind of a circuit. Right? So what we are going to do here is we will take 3 known resistors and connect them in the format of a quadrilateral, and the 4th resistor, the 4th unknown resistor, is used to close and complete this quadrilateral. Right? So having said this, if you look at this kind of a circuit, this is what is called as a Wheatstone bridge. So are you able to understand why we are using this? Right? So those are online, like everybody, are you able to understand that why we are using this?
Yes, sir.
Yes. So mainly what is the purpose of it? It is to find the 4th unknown resistance with the help of 3 known resistances. Right. So when you connect this kind of a circuit, right, where you have a battery connected here, right, then this battery is going to supply current I, and at this junction the current will get split as I1 and I2. Okay, it will get split as I1 and I2. And remember, let's say the current here is going to be IG. Okay, the current here is going to be IG. Then this I4, can I write it as I2 minus IG? Can I write it as I2 minus IG? Right? Similarly, this I3 is going to be I1 plus IG. Right? This is what happens according to Kirchhoff's first law. So I1 is coming like this, IG is coming like this. This is going to be I1 plus IG. I2 is going like this, IG is coming like this. So it is going to be I2 minus IG. Okay. Right. So having said this, now if we start applying the Kirchhoff's voltage law across the loops A, B, D, A. If I apply Kirchhoff's voltage law across the loop A, B, D, A, then when we go from A to B, how many resistors are we encountering? So when you go from A to B, the resistor that you are encountering is R2, and the current across it is I2. So what will be the term that will be written here? It is minus I2 R2 because we are walking in the direction of current. So it is minus I2 R2. Similarly, when you go from B to D, what will happen? Right? When you go from B to D, it is going to be minus Ig into the resistance of the galvanometer. I'll call it as Rg. Okay, it is going to be minus Ig into Rg. Why minus again? Because when you go from B to D, you're going from higher to lower potential, that is in the direction of current itself. Right? Now, when you go from D to A, right? When you go from D to A, it is going to be plus I1 into R1. So it is going to be plus I1 into R1. Everything put together will be a 0 because you completed the loop. Right? Now, if you see, I1 into R1 is equal to I2 into R2 plus Ig into Rg. This is 1. This is 1. Right? The next thing is, if I apply KVL for BCDB, if I apply it for BC, DB, right? So when I go from B to C, right? When I go from B to C, it is going to be I2 minus IG. See, instead of I4, it is going to be I2 minus IG multiplied with R4. So it is I2 minus IG multiplied with R4, and there is a minus sign, right? So when you go from C to D, it is going to be the direction opposite to the current, and it is I3 into R3, but I3 can be replaced with I1 plus IG. So it is going to be plus I1 plus IG into R3, right? That is from C to D. Similarly, when you go from D to B, it is going to be plus IG into RG. Why plus IG into RG? Because you are going from lower to higher potential in the direction opposite to the current. Everything put together will again give you a 0. So clear with these two equations? Are you all clear with these two equations?
Yes, sir. One minute. Okay. See. So this is going to be equation number 2. 1 minute. Okay. So when I rearrange this equation, it is going to be I2 minus IG into R4 is equal to I1 plus IG into R3 plus IG into RG. Okay. So this I will call it as equation number 2. Now, the point to be noted here is there is something called as a balanced Wheatstone bridge. There is something called as a balanced Wheatstone bridge. So this whole circuit is said to be balanced when the value of Ig is equal to 0. When the value of Ig is equal to 0. Okay. So take this and substitute it in each of the first and the second expression that is available. So when you do that, if you substitute this in the first one, you will get I1 into R1 is equal to I2 into R. Similarly, when you take this and substitute it here, you get I2 into R4 is equal to, you put Ig here. So here it is 0, here also it is 0. It will be I1 into R. Okay. So I1 R1 is equal to I2 R2. Similarly, I2 R4 is equal to I1 R3. Okay. Now what I'll do is I'll divide these two expressions. So only thing is before I divide this, I will write it in the reverse. See, it is I1 R3 is equal to I2 R4. The reason I wrote it in the reverse is because here it is starting with I1 and R1, and here it should start with I1 and R3. So I want I1 to be on one side, I to be on other side. So if I divide these two equations, then what I will get here is, so let me call this as 3 and let me call this as 4. So if I divide the third expression with fourth expression,
right? If I divide the third expression with fourth expression, we will get I1 R1 divided by I1 R3 is equal to I2 R2 divided by I2 R4. So I1 and I1 are gone, I2 and I2 are gone. Right. Then what we'll get is R1 by R3 will be equal to R2 by R4. Right. So what you will get is R1 by R3 is equal to R2 by R4. So this is going to be the mathematical expression for a balanced Wheatstone bridge. Okay. So this is going to be the mathematical expression for a balanced Wheatstone bridge. And if you look at this expression, there is one expression and one unknown. So you will be able to solve this problem. You will be able to solve the problems where you are asked to find the unknowns using this particular expression. Okay. So are you all clear with it? Am I clear with the derivation?
Sir,
Tell me.
sir, why do we consider Ig is equal to 0 if
That
it
is
is
when you call it
balanced?
as a balanced Wheatstone bridge.
Sir, any specific reason for that?
Because this part will become an open circuit. Okay. So you people would have written record, no? In that record, did you find meter bridge experiment? You would have seen meter bridge, how it is used to calculate the resistances in series and parallel. If not, you can check it. It will be somewhere around second or third experiment. Okay. So there what happens is, it is a practical application of Wheatstone bridge. So when you need to solve something using a meter bridge, you need to move something. You need to create a change in the electrical circuit so that at one particular point, the current through this galvanometer will be zero, meaning the current through the branch BD will become zero, hence it will become an open circuit. Okay, very simple. Now tell me, let's say the current through the galvanometer is Ig, it is not zero. Okay. Tell me how R2, RG and R4 are connected. Tell me how R2, RG and R4 are connected. How are they? Are they in series or parallel?
Parallel?
Yes. Whereas if I open this, if BD was not existing, then how is R2 and R4 connected?
Series.
That's what happens. So you understood the circuit which was parallel gets converted to series. Okay, so by you forming this kind of a circuit, when you open this, you will be able to frame a relation between them. So this relation, when you do it experimentally, because see, all these things are not theoretical ones, they are all experimental ones. So galvanometer, it's not theory, it is a real-time thing. Okay, are you able to understand what I'm saying?
Yes, sir.
1 minute, listen, I'll come back, just give me a minute. Are you able to hear me?
Yes, sir.
See, this is how a galvanometer actually will look like. Okay. So you're able to observe there is a needle here. Right? So galvanometer is basically what kind of an instrument? You would have learned in your 10th grade. I'm asking now to recollect things. So what is galvanometer basically? It is a guys, can you please speak? So what kind of an instrument? Is it a measuring instrument or something else?
Measuring instrument.
That is where we think it is measuring. It is not measuring. It is only a indicator. Okay. It will only be used to detect the presence of current. It cannot measure the value of current. That is why if you see, where is the pointer?
0.
0, no. So this is the positive terminal of the galvanometer. This is the negative terminal. When you take these things and connect it to the circuit like this. For example, if you look at the point B is connected to positive terminal of the battery. Sorry, A is connected to the positive terminal of the battery. C is connected to the negative terminal of the battery. Am I clear? So when you do this, based on the way the current is flowing, if current flows through this, it is a sensing device. It will tell whether current is flowing or not. If current is flowing in one particular direction, let's say this pointer is turning in the clockwise direction. If you reverse the direction of current, it will turn in the leftward direction. Okay. So if you can balance this circuit, if you can bring a balance in the circuit by making the pointer stay at the center itself, then you say this kind of a circuit is a balanced Wheatstone bridge. Okay. So when balanced Wheatstone bridge means what is the current flowing through this galvanometer? When the pointer is at center, it is going to be
0.
Right. That is when it will help you. This circuit will actually open up this branch and make the resistors R1 and R2, R4, sorry, R2 and R4 get connected in series. Similarly, R1 and R3 get connected in series. Okay. Am I clear with this?
Yes, sir.
Yes. So make a note of this and let me know once you're done. So waiting for your response. Let me know once you're done. Okay. You can copy it, but try to absorb the concept. Try to absorb it.
Done, sir.
Yeah, coming. Yeah, shall I proceed? Yes. So we'll do a problem that is based on Wheatstone bridge. So if you look at example 3.7, the four arms of a Wheatstone bridge have the following resistances. AB is equal to 100 watt. Sorry, there is a mistake here. It is not watt, it is 100 ohm. This is 100 ohm, and ohm. Okay. So listen to this. The four arms of a Wheatstone bridge have the following resistances. AB is equal to 100 ohm, BC is equal to 10 ohm, CD is equal to 5 ohm, and D is equal to, DA is equal to 60 ohm. Okay. I think I didn't copy the question completely. Can you just look at the text book and tell me what are they expecting? They want the values of I1, I2, I3. I think you're asking the values of I1 and I2, right? Can you open the textbook
Current
and
through
check?
the galvanometer and the potential difference of 10 volt is maintained across AC.
Okay, what is asking? Calculate the.
Current through the galvanometer.
Oh, you need only the current through the galvanometer. Okay. So observe. See, though this problem is actually based on Wheatstone bridge, you cannot directly say, if you observe, the relation is very simple. R1 divided by R3 means the ratio of the resistances that are nearby or in the neighborhood, R1 by R3 is equal to R2 by R4. Okay. So here I cannot use that 60 by 5 will be equal to 100 by 10. Why? I cannot use 60 by 5 is equal to 100 by 10. First of all four are known to us. Right? All the four resistance values are known to us. Am I right? Second most important thing to be noted here is this is not a balanced Wheatstone bridge. Why? This is not a balanced Wheatstone bridge. Why?
Sir, is this because they have asked us to find the current of the galvanometer and
So they see, maybe when they say current in the galvanometer, IG value can come out to be 0 also. 0 is also a number. So just because they told about find the value of IG, it need not be that it is not a balanced Wheatstone bridge. But remember, whenever you have a balanced Wheatstone bridge, the ratio of their resistances in the neighborhood will be the same. For example, R1 by R3 on the left hand side is the same as R2 by R4. So left hand side resistance divided by right hand side resistance at the bottom will be equal to the LHS divided by RHS at the top. So if that is the case, what is 60 by 5? 60 by 5 is 12, whereas 100 by 10 is only 10. It is not a balanced Wheatstone bridge. Because if I take this as R1, R2, R3 and R4, R1 by R3 is not equal to R2 by R4. R1 by R3 is not equal to R2 by R4. Is the point clear? So that is why it is not a balanced Wheatstone bridge. So all that you need to do in this problem is you need to apply Kirchhoff's voltage law. So when you apply this ABDA, when you go from A to B, right? When you go from A to B, you're walking in the direction of current. So answer will be minus 100 I1. Right. Similarly, when you go from B to D, it will be minus IG into 15. Similarly, when you go from D to A, it will be plus 60 into I2. Everything put together is 0. So everything put together is 0. So
60 I2 is equal to 100 I1 plus 15 IG. This is 1. Right? Right. Similarly, if you look at BCDB, right? When you go from BCDB, when you go from B to C, it is I1 minus IG into 10 with a negative sign. I1 minus IG into 10 with a negative sign. When you go from C to D, it is going to be plus I2 plus IG into 5. Similarly, when you go from D to B, it is going to be plus 15 IG is equal to 0. Right? And the last part is taking A, B, C, D, E, F, A. Okay. If I take the loop, A, B, C, D, E, F, A, then when I go from A to B, it is going to be minus 100 I1. When I go from B to C, it is going to be minus of I1 minus IG into 10. So when I take a complete loop, it is going to be plus 10 is equal to 0. Right? So here what will happen is 100 I1 plus I1 minus IG into 10 is equal to 10. So 10 will cancel this like this. So you will have 11 I1 is equal to IG plus 1. Okay, 11 I1 is equal to IG plus 1. Or you can say IG is equal to 11 I1 minus 1. Take it and substitute it in any one of the equations. Then you will get two linear equations, solve it, that will give you the answer. Did you understand what you're supposed to do?
Yes, sir.
Yes. So first copy this. Let me know once you're done.
You're done?
Yes, sir.
Okay. So I'll tell you how to solve this. Okay. So what you need to do is from here, one minute, guys. Okay. So this one. 60 I2 is equal to 100 I1 plus 100 I1 plus 15 IG. Okay. Next. Eleven I1 is equal to IG plus 1. So from here, what I can do is I can take IG is equal to 11 I1 minus 1 and take it and substitute it here. Or what I could have done is, okay, I1 will become IG plus 1 by 11. So it is better. So 60 I2 is equal to 100 I1 plus 50 into 11 I1 minus 1. Okay. So this will become 60 I2 is equal to 100 I1 plus 15 into 11 is 150 plus 15, 165. So 165 I1 minus 15. Right. So 60 I2 is equal to 265 I1 minus 15. Okay. Next is this part. If you take BCDB, can someone tell me what is the equation 50? Minus of I1 minus IG into 10
Plus I2 plus IG into 5
plus I2.
plus IG into 5
Okay.
plus 15 IG equal to 0.
Plus 15 IG equal to 0. Okay. Now what I can do is, in the place of IG, can I substitute this one? 11 I1 minus 1. So minus of I1 minus of 11 I1 minus 1 into 10 plus I2 plus 11 I1 minus 1 into 5 plus 15 into 11 I1 minus 1 is equal to 0. So minus of minus 10 I1 plus 1 into 10 plus 5 into I2 plus 11 I1 minus 1 plus 15 into 11 I1 minus 1 is equal to 0. Okay. So take the minus sign inside. It will become 10 I1. Actually, it will be 100 I1 minus 10 plus 5 I2 plus 55 I1 minus 5 plus 165 I1 minus 15 is equal to 0. So what will get combined? 100 I1 plus 165 I1. 100 I1 plus 165 I1 is 265 I1. Are we getting the same equation again? So 265 I1.
Sir, you have 55 I1 also.
Oh, plus 55 I1 is how much is the total coming to? 155 plus 165. How much is it? 320.
320, sir.
So 320 I1, right? 320 I1. It is 5 I2 is equal to 320 I1 minus 15. Am I right?
The 30
Yes, sir,
should
minus 30.
Minus 30. Okay. Minus 30. What you can do is cancel out with 5. So 5 will cancel this how many times? 64. And this will go 6 times. So I2 is equal to 64 I1 minus 6. T. So 15
Sir,
will
it should
cancel
be
this.
I2 equal to 6 plus 6 minus 64 I1.
Come again.
I2 should be equal to 6 minus 64 I1.
It is 6 minus 64 I1. Huh?
Mm.
Why is it so?
Sir, because
Then tell me the above equation.
sir, I got it as 320 I1 plus 5 I2 is equal to 30.
1 minute. 320 I1. Huh? Okay.
320
320
I1
I1.
plus 5 I2
Hmm.
is equal to 30.
Is equal to 30. So how much will this come to? 64 I1 plus I2 is equal to 6. So this is what you told. I2 is equal to 6 minus 6. Okay.
Yes, sir.
So similarly, here 15 will cancel this 11 times, this 4 times. So can I write 11 I1 minus 4 I2 is equal to 1? Can I write it as 11 I1 minus 4 I2 as 1? So this I will multiply it with 4. So when I do that, 64 into 4 is 256. So 256 I1 plus 4 I2 is equal to 24. Right? So add them. 256 plus this is 267. So 267 I1 is equal to 25. So I1 will be equal to 25 divided by 267. So I1 is equal to 25 divided by 267. Okay. Now take this value and substitute it here. That will give you the value of Ig. Clear with that? Are you clear with that? What the value of Ig?
Sir, I'm getting something like 8 by 267.
8 by 257, huh?
8 by 267.
8 by 267. So, what is the answer given in the textbook? Can I take it as 2.9 into 10 power minus 2? Yeah. So 2.9 into 10 power minus 2 ampere. What is the answer given in the textbook?
So 4.87 milliampere.
4.87. Huh?
Yes, sir.
I think there is a calculation mistake here. Okay. So I think there is a calculation mistake somewhere. So 2.9 means approximately the answer given in the book is approximately 1.5 times more. Right. But I hope you could understand the concept, no? Right? You understood when to apply the balance Wheatstone bridge and when not to apply the balance Wheatstone bridge? Yes or no?
Yes, sir.
Yes, sir.
Very good. So this is all about chapter 3. So this comes to the end of theory. Right, but as I promised, right, I'll be doing a lot of problems based on this chapter. I'll concentrate a lot on the previous year questions, like how we did for electrostatics, right? I'll concentrate more on PYQs, the previous year questions. Okay. So I hope the theory is completely clear to you all.
Yes, sir.
Yes, sir.
Yes. So that's good. So for today, I'll wind up with this. Tomorrow, hopefully, I think there should not be this much of rain and we'll have an offline class. If not, if the climate is still bad, I'll update on what is supposed to be done. Okay. So any other questions? Nothing? Okay, we shall wind up this.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.